All right, I'm going to apologize for the audio ahead of time. I'm at home making this video, and the microphone on my laptop isn't quite as good as the one that I use at school, but I think it'll do just fine. So, really quick, what we're trying to do is we're trying to solve quadratics, and quadratics are in many forms. Most quadratics are in standard form, which would be like, x squared plus 6x plus 5. That would be something considered standard form. So I'm going to say STD form. And when we factor it, like we did before, we factor this thing, and that would be like x plus 1 times x plus 5. And this would be what we're calling factored form. And then there's vertex form, and there's other forms of quadratics. But the big idea about a quadratic is you know it's a quadratic when its highest power is a 2. All right, so that little 2 right up here, that tells me that it's a quadratic. And it also tells me that I'm usually going to have 2 solutions. So there's not going to be just one solution. There's going to be 2 solutions. So unlike normal algebra problems where, if I just said, hey, solve 3x plus 5 equals 11, well, you can get x by itself by doing the opposite to both sides and eventually get one answer. You can't get these ones by themselves because, you have a couple different x's going on. So today we're just going to focus on 3 things. We're going to solve quadratics in factored form. We're going to find zeros of a function and then use zero product property. And then we're going to graph in factored form. So we start off pretty easy today. So this is your homework, and basically I'm just going to do 3 or 4 of these with you to kind of get you going. So here we go. So number 1, it said find the solutions for each equation. So in this first one, I see that I have some expression times another expression equals 0. And what we can do to solve this is we can use the zero product property. Basically, it says this. It says that if A times B equals 0, if 2 things are multiplied together to make 0, then something has to be true. Then either A equals 0 or B must equal 0. One of those 2 things have to be true. That's the only way you can multiply, which product is just a fancy word for multiply. It's the only way you can multiply 2 things and get 0 is if one of the 2 things are 0. So we need to find out when the parentheses are going to be 0. So I'm going to set these up. So the first one, when is x minus 2 equal to 0? Well, that's 0 when x equals 2. And when is x plus 5 equal to 0? Well, that's going to be 0 when x equals negative 5. So what I just found, these two answers here, these 2 answers are solutions to the equation, meaning if I plug them in up here, they make the equation true. Now I'm going to do one more because a lot of people might be like, oh, it's just the opposite of the numbers in the parentheses. And it usually is, but on number 2, you'll see it's a little bit different. So on number 2 here, I'm going to set this one up and I'm going to say, well, when is 2x minus 1 equal to 0? Well, when I add 1 to both sides, we get 2x equals, not 2, sorry about that. We get 2x equals positive 1. And then when I divide, I get an answer of x equals 1/2. So there's one solution. Now the other side is pretty easy. Try to do this in your head. Subtract 3 from both sides, and we get x equals 3. So in this whole top section, all we are doing are finding solutions to the equation. Now I'm going to leave 3 through 6 for you for your practice. And we're going to go down to number 7. Now, number 7 is worded a little bit differently here. It's where it says find the zeros of the function. Now, zeros are basically the same exact thing that we just did up above. And it's just written in function notation. So notice that you have this h of x. So that's function notation. If the SAT were to ask this question, a lot of kids will miss these because they're not really sure what it's asking. But when you want to know the zero of the function, you want to find out when does this thing equal 0. So it's the exact same thing as above, just the wording is a little bit different, but I'm going to do this example with you. So for the first part, let's set this side equal up to be 0, and we'll solve it. We'll minus 3 from both sides, and then we'll divide both sides by a -2, and that will turn into x is a positive 3/2. And this other one, when I do -x plus 3 equals 0, and I can either move the 3 to the other side, so maybe I put the 3 to the other side, make it negative, and then I have to divide or multiply by a -1, which just changes the signs, and I end up with 2 answers. So these are also known as zeros of a function when it's written in function notation. So a lot of times you will hear teachers and you will see the SAT use these words interchangeably. Zeros, solutions, and sometimes they're called the roots. So these are all words that kind of have the same type of a meaning. So I'll leave 8, 9, and 10 for you to do. Now we want to get into the graphing. So graph quadratics in a factored form. So I'm going to give you some steps for graphing. I think I'm going to do number 12 for you on this one. So number 12 will be our notes. So if I look at here, the very first thing I want to do, so step 1, when I want to graph, I'm going to find the zeros of the function. So I'm going to find the zeros for this function, and then I want to plot them on the x-axis. So let's find the zeros of the function. Well, I think we probably good enough where we can just kind of do these ones as is. To find the zero of this, well, that parenthesis is 0 when x equals -2. So I'm going to put that dot right on the x-axis at -2. And then the other one is going to be at x equals -6. So I'm going to put that dot right there. And I found my 2 zeros. So step 1, bam, got our zeros. Step 2 is we need to find our symmetry line. So the symmetry line, and you probably did this in advanced algebra, but the symmetry line is the midpoint of the zeros. So for instance, somewhere in between those 2 dots, exactly in the center, is going to be the vertex. So I'm going to kind of draw this line, try to draw it really light here. It's kind of coming down. So right there is the symmetry line because -4 is exactly in the middle of my 2 zeros. So kind of what I want to keep in mind over here, we're actually creating some ordered pairs on a chart. I've got my 2 zeros. So when x is -2, y is 0. And when x is -6, y is 0. So those 2 dots are on the graph. What I want to find now is I want to find the symmetry line. And since the symmetry line is at x equals -4, that's the symmetry line, I want to plug that in the equation, and I want to find the y value. All right, so I'm going to stick -4 in this equation, and I want to solve it and see what we get. So up above here, I'm going to have 2 times parentheses, and that's -4 plus 2. And then I'm going to have my other parentheses plus 6. And let me plug my -4 in there. And so now when I multiply this out, there's no need to distribute. We can do what's inside parentheses first. So I have 2 times a -2 times a positive 2. So 2 times negative 2 times positive 2 turns into be negative 8. So what I've just found, this is a super important point, what I've just found here is I've just found the vertex. That was the whole point of this symmetry line, is I want to be able to get the vertex. So the vertex is my X and Y combination that I get from over here in this chart. And let's put that dot on here, negative 4, negative 8. Boom. Now I have a really good idea of what my graph looks like. So looks like my graph is going to come down, go back up, and there we have it. So we have a parabola that's really skinny that opens up. So the 3 key features, or the 3 points that you should have on your graph, are the 2 zeros. So let me just write this up here. 3 key features need to be your 2 zeros and the vertex. All right, that's what I need to see on the graph, and we can see those points clearly right. Let me make it in blue. Right there, and right there. So that's what I'm looking for in the graphing problems. All right, I'm going to leave the other 3 up to you. This assignment is due tomorrow night at midnight, so snap a picture of a PDF and pop it in the Schoology file. See you.